Hello, geometry. I am sorry I couldn't be there, but have no fear. I am still here. Okay, so I want to give you your lesson here on 5-6 so that you're not having any trouble. But before we get going into actual lesson, I want us to think back to this top inequality there. If A equals B plus C, then C is greater than A, and then A is greater than B. So let's just pick some values. So if we have something like that, and we just make a true statement out of it, then what they're saying is, then A has to be bigger than B. Okay, so there's no way, as long as this was bigger than 0, which was a requirement, as long as this is bigger than 0, there's no way this number could be bigger than this. Okay, so we use that just with base inequalities and logic. Now we're going to bring it into triangles. But first, before we do that, can you look at this picture? You will see you have a what here? Linear pair. I heard you all saying that. Good job. Linear pair. So when it asks you what is the measure of angle ACB, that would be 60 degrees, correct? 180 minus 120. Now what are the possibilities then for this? Do you remember the triangle inequality theorem that told you that this is equal to these two added together, angle A and angle B? So what does that tell you about each of them individually then? If when you add them you get 120, what does that say about A and B individually? They each would have to be less than 120. Right? So if this is 1, this is 119, this is 20, 100, 60. 60 is probably more likely the answer there. Looks like an equilateral triangle. But anyway, so that thought we're going to carry now into the lesson for today, which is leads to the corollary to the triangle in exterior angle theorem. Remember, corollary is a theorem where another theorem is used to prove it simply. How's that for a mouthful? But let's take a look at what it's saying. We know that this is an exterior angle, correct? So we're going to talk about that relationship again to these two. And above, you told me that this is equal to these two together, and when we analyzed what that meant, it meant each of these had to be less than this. So that is exactly what they're talking about now in this theorem. They're saying, okay, we know 1 is equal to 2 and 3 together, so individually 1 has to be bigger than 2, and 1 has to be bigger than 3. Because together they equal it. So let's look at this now. There's a whole mess of stuff going on here, and it says, why is the measure of angle 5 greater than the measure of angle C? Well, first you have to allow your eyes to zone in on the right triangle, don't you? 5 is an exterior angle to which triangle? I shall find my highlighter for this. There you go. So now it's a little more clear, isn't it? I'm not even sure that information is even needed inside. In fact, I know it's not. But it's still, it's a skill to be able to look at a whole picture and try to let your eyes see it in different ways. So in this case, when we look at it here, we have 5 is the exterior angle to this big triangle. So 5 has to be bigger than C because it's equal to C and number 3 here together, doesn't it? So angle 5 is I'm just writing this out because I'm not there, in case you missed something, is an exterior angle to triangle ADC. Why did I write B when I said D? And so, measure of angle 5 is greater than measure of angle C by this theorem. Let's highlight that. Let's not even box it. Let's highlight it. Triangle exterior angle theorem. I suggest you do the same on your note sheet. By triangle exterior angle theorem. There's my abbreviation. Okay, so let's look at the bottom now. So we're just looking at a bunch of different connections now. This is going to talk about going, looking at inequalities. So you first have to find what they're saying and not get lost in all this, okay? XZ. Where's XZ? Right here. They're saying that is greater than XY. Where's XY? Right here. Okay, so this is the larger side and this is the smaller side. I'm just going to put L and S just for larger and smaller. So if that's the case, this theorem 510 can tell you that when you look at the angles across from them, they have the same inequality. So the angle across from the largest side, which is at angle Y, is also bigger than the angle across from the smaller side, which is angle Z. So you're given an inequality about sides and you're making a conclusion about an inequality with the angles across from those sides. All right. Let's look at the back here. Okay, did I go too fast? Did everybody get that? Okay. All right, so when we look at this, suppose that the architect wants to place a drinking fountain at the corner with the second largest angle. Which streets form the corner with the second largest angle? Okay, well, first of all, I don't even have names of these, so that's a problem. So this is MLK Boulevard, and this is Valley Road, and that is Hollingsworth Road. All right, so we need to, again, let's read it again. Remember, we do that with word problems. Suppose the architect wants to place a drinking fountain at the corner with the second largest angle. So we got to figure out which the second largest angle is. Well, it's across from the second largest side. So we need to find the second largest side. All right, I'm gonna get my highlighter. Let's look at our numbers here. 105, 120, 175. This is clearly the second largest side. So the second largest angle would be across from it. It would be this angle right here. And to answer the question properly, it says which streets. So we need to look at now what intersection is that. It's MLK Boulevard and Hollingsworth. So MLK Boulevard and Hollingsworth. All right. Now we're going to make another connection, but it's going to go the other way. So now we're going to go from angles to sides. So in here, they're saying, okay, but let's say you only know the angles. And it says measure of angle A is bigger than measure of angle B. And I love this because look at, they make the angle here more filled in than that one. Or is it just because it's smaller? I don't know. It's hard to tell. But that is the larger angle and that is the smaller angle. So therefore, the side across from the larger angle, which is here, is bigger than the one across from the small, which is here. So just the reverse of what you were just doing, just a converse. So let's look at this now. Measure of angle S is 24. Measure of angle O is 130. Which side of the triangle SOX is the shortest side and why? So what we need to do first. Exactly. You have to figure out what the third triangle is, or third angle. So we know triangle sum theorem tells us that these add up to 180, correct? So 180 minus 130 is 50, minus 24 is 26 degrees. Now we can figure it out. I want the shortest side. Okay, so which one has the shortest angle? Right here. 24. I'm going to go to the side across from it. The side across from it never touches that angle. So that is the side across from it. So the answer would be OX. And why? Theorem 511. Or you could just say, try to explain that. That would be fine too. And lastly, this is called the triangle inequality theorem, or otherwise known as the common sense theorem. All right. XY plus YZ is bigger than XZ. And YZ plus XZ is greater than XY. And XZ plus XY is bigger than YZ. So what is it saying in all that? It's saying any two sides are always going to be bigger than the third side. There's no way you could have two sides of a triangle that are smaller than the third side. It wouldn't give you a triangle. And we can try that in class sometime if you think you can picture a way that it would happen. There's no way they would meet. So when you are talking here, can this triangle have the given lengths? Well, you got to make sure you can make a triangle out of it. So you'd have to check them. I'm gonna start with all three combinations is what you should check. And check, is 2 plus 6 going to be bigger than 9? No. I already have my answer. This cannot be a triangle. But just for good measure, I want to show you the other one. So 6 plus 9, can that be bigger than 2? Yes. And can 2 plus 9 be greater than 6? Yes. So the other two were fine, but it was this first one that does not work. They will not be able to connect those corners. There won't be enough room to put these, to connect these two at the corners of that one. And it should kind of make sense too, because if you think of, like, let's say this is 9. Well, if you lay down on top of it a 2 and a 6, it's not even, oh, somebody's here. Wow. Okay, that scared me. So it's not even going to be that long to meet. There's no way I could then lift it up and have it meet that. So, all right, let's check this one. 4, 6, and 9. So let's check all three. 4 plus 6, is that greater than 9? I don't know, you do it. 6 plus 9, is that greater than 4? 4 plus 9, is that greater than 6? I just picked all three combinations. You determine if they all work or not. Yay! It works. And that is it for today's lesson. I'm going to do another lesson that goes over the questions from yesterday's homework. So you can use that as well if you'd like. Okay. Be good for Mrs. Peters. Take care. Bye.